Okay, today's topic on options valuation is very fundamental to your learning options. Okay, you have to be able to fully grasp today's fundamentals so that you find that going forward is going to be much easier. All right, so I'm going to suggest to you that one way to be able to fully grasp today's lecture, and indeed every lecture, is to think as I explain the lecture. Okay, so that way you can follow the logic better. Because if you try and just listen and remember, you find that it's going to be quite difficult for you moving forward. So if you start from today and think while I explain, you'll find that you can follow the logic better, and that will help you when it comes to your exam. Okay, because even if you forget, but you can understand the rationale behind it, you can actually figure out for yourself what the answer is. Okay, so try to think instead of just listen. So I'll start off with some standard notation. So every lecture I'm going to introduce to you some new terminology, some new notations as they are relevant to that topic. So make sure you know them well. Okay, before I forget, how many of you have got a lecture or something else on Tuesday 11 to 1? Do you have something else going on on a Tuesday 11 to 1? Yes or no? Nobody has anything else on Tuesday? You have? What is that? Is that a lecture or? Lecture. What is that? Sorry? Risk management. Anybody else? Many of you, yes? Okay. So quite a few of you have something on Tuesday 11 to 1. Okay, I also have some discount vouchers in my office. I wanted to bring it here, but it was raining and I was in a rush, so I forgot. But if you want to get a textbook, you can come and grab it from me. I have discount voucher for you if you want to buy a textbook. Okay? Okay, with option boundaries, we will look at rules that govern rational option pricing. Okay, so what that means is that we will look at rules that helps us to establish what the maximum value an option can take, and also what the minimum value an option can take. So that helps us to establish a range, right? Now it's useful to establish a range because if we know what the maximum value an option can take, or the minimum value, then it helps us to decide whether or not, for example, to exercise our option at that point in time, right? Because if we know that at that point in time the option value is the greatest, then it makes no sense for us to wait anymore, because in waiting we may find that our option becomes out of money, right? So it's a useful tool to have. However, at this stage we still don't know what the value of the option is. Okay, so we'll look at that when we learn how to price options in the next 2 weeks. And there are a number of factors that has an influence on the value of an option. Okay, so these are the factors that will also be used as input in your pricing model, whether it's a binomial or a Black-Scholes model later on. So it's important for you to understand what these factors are and how they affect the value of an option, because later on in 3 weeks from now, we're going to see how small changes in any of these variables is going to affect the value of an option, how sensitive your option is going to be relative to small changes in each of these. Okay? Who knows what these variables are? Who knows what these factors are? Give me one. Time, right? That's the first thing that comes to your mind, isn't it? But don't forget the underlying. Okay, the underlying is very important. And then we'll look at put-call parity. I briefly touched on put-call parity last week. Put-call parity would basically establish the relation between a call, a put, a stock, and a bond. Okay, and when we know that relation, it helps us to also value an option, although that's relative pricing. the binomial and Black-Scholes will give you a more accurate pricing, but put-call parity can also help you to establish a relative pricing. So a quick back-of-the-envelope pricing if you would. And as I mentioned last week, it also helps you to establish the payoff of one of the components if you know the rest. Hang on, did I record? I did. Okay, the next 3 slides on compounding and discounting, continuous and discrete, I won't explain in detail because a lot of you should know by now. But briefly, what you want to remember is that in your exam and your assessment, in anything that you do with derivatives, you should always use continuous, compounding, or discounting. In other words, you use the exponential term. Okay? In my slides, I'm going to show you examples of both discrete and continuous so that you are able to do both. Now, some of you may think that the binomial is a discrete model. Indeed, in a sense, it is a discrete model. Now, discrete model means you view time in small parcels, right? In fixed parcels. So it can be 1 minute, 1 hour, whatever you decide. Now, in reality, time isn't that way, right? Time is continuous. So if you slice the binomial model in small enough time intervals, then it approaches real time, which is what we'll be looking in that show. So there's a distinct difference between the two. Okay? So if discrete, you use 1 plus r. If it is continuous, you always use this exponential term. Now we say that the absolute minimum value of a call is equals to 0. Now can anyone tell me why do you think it's equals to 0? Why can't it be anything else? Now you know that what is the payoff of a call? What is the payoff of a call? What's the value of a call at expiration?
So it's the difference between the stock price and the exercise price.
Okay. Underlying price, right? If you're looking at something else, then it's something else. So the difference between S and X. Now, the difference between S and X can be negative, right? Yeah. Yes or no? So why do we say that the absolute minimum is equals to 0?
Because if the exercise price is below the stock price, I will not implement my call option or put option.
So you make a loss, right? Because
yes, I make a loss, so I will not implement my call option.
So you will not exercise, right? The correct term to use is exercise. So because you only have the right, but not the obligation, so therefore you can say that it's equals to 0 to you because you don't have to take up the liability, right? Very good. So I'm going to just recap something that I mentioned last week before we go forward. So the value of an option is equals to what? Intrinsic value, right? What is this? Equals to intrinsic value plus time value, right? Now, when you exercise a call or put for that matter, what do you get? You only get intrinsic value, right? Because there's no more time value, you're not holding it anymore. So two things can happen. One is when S is greater. Now remember, we're talking about going long a call, okay? So 1 or S can be less than X. Now, when does a call becomes 0? The absolute maximum, minimum value of a call becomes 0. What happens when S is greater than X? Is your call positive or negative? Positive, right? and this becomes negative, right? Now, when would it become maximum? Or what is the maximum? S, right? When x equals to 0, right? And what about this one? What is the minimum? 0, right? When does that happen? When it's out of the money, right? So this helps you to establish what is the maximum and what's the minimum value of a call. And you can use the same logic to determine a put as well. However, this is just the intrinsic value. Okay, so you have to take into account time value as well. Now, can time value be negative? Or is time value positive or negative? What do you think? You think it's positive. Can it be negative? Can. When is it negative? Well, not so much as that, but we'll come to that. Okay, now time value can also be negative, okay, but not often. So therefore we say that the minimum value of a call is equals to 0, and why do we then say that, you see this inequality sign here, we say that the value of a call is greater or equals to the greater of 0 or s minus x. So when it's out of the money, it's equals to 0, right? But we say here that it's greater or equals to 0. Why is that so? Because of time value, right? There's always time value, which is why you find out of the money options are still trading in the market for price. Now, notice also that there's a difference between European and American call. With American call is simply s minus x, European is s minus present value of x. The reason for that is, of course, whenever you exercise an American option, you pay x, right? However, with European options, you cannot exercise. And if you were to pretend that you're going to exercise it today for comparison, then of course you have to take the present value of x, because in today's terms, you're not paying x, right? You're paying x in the future, okay? So here I have a graph that shows you the value of a call. Now, a stock price increases beyond x, your intrinsic value becomes positive, right? So your call is in the money. Now, if you were to short a call, how do you think this graph will look like? Like that? Like that? What do you think it will look like? So this way. That's correct, right? It's a mirror image of this. Okay, so what that means is if you were to short a call, as stock price goes beyond X, you start to look at a loss, right? Because it can be exercised on you. So if you look at the intrinsic value, if you were to short a call, can it be positive or negative? If you were to short a call. Okay, to help you out, is this positive or negative? This is a long call. Is this positive or negative? Positive, right? Can this ever be negative? No, right? Because you only have the right. Okay, now if you short a call, what is this value going to be? This is still 0. What is this value going to be? Positive or negative? Negative, right? Yeah?
X minus S.
Yeah, but because you short a call, you put a minus sign to the whole term of s minus x, right? So it's negative. Because now you're dealing with obligation, not right? You can't walk away. So can it ever be positive? No, right? Very good. Okay, what I have here is what is called a payoff table. Okay, a payoff table is very useful, so it might be worth your while to know this well, because sometimes when you're asked to prove certain things, you want to make use of a payoff table to do that. Okay, so consider two portfolios. You create a first portfolio for which you long a call and you long a bond. So essentially what this means is that you know you're going to have to pay the strike price at expiration, right? So you invest or you put the present value of the strike price in a bank to earn you the interest rate. Okay, so by the time T expires, you have X. Okay, does everyone understand this? Okay, and you create another portfolio where you go long a share. So whatever happens at expiration, the share price is the share price at expiration, right? So it's ST. Now, which of these is bigger, A or B? A is bigger, right? So what it gives you? This is X. This is ST. Same as ST. This is ST. So X is greater than ST, right? So A is greater than portfolio B. So you could therefore say that a call plus a bond is greater than a stock. Now rearranging it gives you a call is greater than S minus your bond. Okay? Does everyone follow? Now if this were not true, is there an arbitrage opportunity? Okay, I want to emphasize that in this course, you must be able to identify an arbitrage opportunity, and you must also know how to capitalize on that opportunity. Okay, it's always arbitrage, hedging, speculating. So is there an arbitrage opportunity here? So suppose stock is trading at $103, strike price is $100. What is your call? What's the value of your call? $3, right? Now suppose this relation here, as we saw on the payoff table, is not true. Okay? Now suppose the call is trading at $2. Do you have an arbitrage opportunity? What do you think? What can you do? What is the arbitrage opportunity? So instead of $3, the call is now trading at $2. What can you do? Is that underpriced or overpriced? Underpriced. So if it's underpriced, what do you do? What do you do? You buy? Buy the call? Okay, so you buy the call, you pay $2, and what else do you do? Exercise it, and you pay $100, right? The strike price. And in doing so, you acquire the stock. Yeah? And then you sell the stock for $103, so you get $1 profit, right? Risk-free. Now, if this were $4 instead, do you still have an arbitrage opportunity? What do you think, man? If you were $4, what do you think? Sell the call. And what do you do after that? Exercise. You don't exercise when you sell the call. What do you do? Buy back one. Buy back one. Okay, so you're saying that you sell the call at $4, and because last week you learned about arbitrage and law of one price, right? So you're saying that now you sell the call at $4. When prices move back into equilibrium, which is $3, you buy back the call, you still make $1 profit, right? Very good. What else can you do? I know you wanted to say something. What else can you do? So you still sell the call?
Yeah, sell the call, but I will hope that the holder will not exercise.
Oh, but the holder will exercise just like when it's underpriced. So the only difference is whether the call is overpriced or underpriced, right? But it's still in the money. So just like when it was $2, you exercise your call. Now, even though the call is at $4, somebody who buy the stock will still, the option will still want to exercise. So you sell your option at $4, and what happens after that? What about you? Yeah, the one is red. What do you think? Do you agree that you will sell the call?
Yeah.
Okay, and what do you do after that?
Buy.
Sorry?
Buy it later.
Buy back later.
Yeah.
So just like the lady. What do you think? Sell the call and buy back. Okay, if you sell the call, how much do you get? $4, right? Now, if the call is going to be exercised just like in this case, you have to deliver the stock, right? Yeah? So you deliver the stock for $103. Yeah? Agree? Because you have to buy back from the market and deliver, right? But you also receive $100, right? Yes or no? Because you short the call, right? So you receive $100 being the strike price when somebody else exercises. So you still make a dollar, either way, right? So whether or not it's under or overpricing, you find that you still can arbitrage on that and you still make a dollar profit. And of course, like the lady says, you can also just sell it back to the market, okay? Or rather buy back from the market. Okay, I have a June call. Now the way to read this is always STX, right? This is the price of the underlying. This is the time to expiration. Remember, it's always 365, and this is the strike price. So it's trading at 52 cents. Is this in or out of the money? Out of the money. So why is it trading at 52 cents? Time value, right? Okay, so time value essentially is the speculative value. Notwithstanding that the option is out of the money, there is hope that it will become in the money as the underlying price move. Okay, so that's speculative value. So how much is time value here? 52 cents, right? Because intrinsic value is 0. So the longer you hold to, the longer time there is to expiration, the higher the time value. Now that makes sense because you have a longer time to hope for the call to be back in the money, right? So absolute maximum value of a call here is equals to 0. Now when does that happen? When strike price is equals to what? And strike price is equals to what? When does a call value equals to S? Equals to 0, right? Now, in reality, that can never happen, right? I mean, who is going to sell you a call for which you can exercise for 0 value? You don't have to pay anything to exercise the call. It's not likely to happen, right? So it must be the same for American and European call, okay? Why do you think why do you think this is going to be negative? Going to be less or equals, and not simply equals? Well, that's because an option has a limited life, right? Option expires, okay, whereas a stock is perpetual, okay? So what is the value? Now notice that when we talk about maximum and minimum, we always have that inequality sign, greater or equal or less or equal. Now what happens at expiration? It is simply equal, right? There's no ambiguity about it. It's always the greater of 0 or intrinsic value. The reason for that is because at expiration there's no more time value, okay? So it must be the same for European and American, because when an option expires, of course, the right to or the ability to exercise early also disappears, right? Any question? Okay, then we look at time to expiration. So we have two American calls differing only by time. So T1 is less than T2. Which call do you think would be worth more? The longer dated call or the shorter dated call? What do you think? Longer. Why longer? Because of greater time value. Okay, but that's in the case of a call. Okay, in the case of a put, it may be different. Okay, so take note of that. it doesn't mean that just because you have a longer time, it is always better for you. So at time t1, the first call is equals to intrinsic value, whereas that will be the minimum value for call 2. So you can think about it this way. So if you have T1 here, T2 here, so T1 is less than T2, right? So for call 1, what is the value at T1? Call 1 expires in T1, call 2 expires in T2. What's the value of call 1? At this point in time? It must be only the intrinsic value, right? Because it expires in T1. Now, what is the value of call 2, which expires in T2? It must be intrinsic plus time value because it still has so much time to expire, right? So there is time value, okay? So what about these two intrinsic value? Are they the same? They must be the same, right? Because they are in respect of the same underlying, and you have the same strike price. So S minus X must be the same in both cases. So in fact, you don't have to remember the slide. You just have to have this picture in your mind, and you can work it out yourself. Okay. Okay. So time value is maximized at the money and minimized when it's dipped in or out of the money. Why is that so? What is time value? Speculative value, right? So why is time value maximum at the money and minimum dipped in or out of the money? Now remember, time value is speculative. So when an option is at the money, any small movement can cause the option to be in or out of the money, right? Agree? So therefore, time value must be highest there. Now, if an option is deep in or out of the money, small movement is not going to affect much, right? It's still going to be deep in the money or deep out of the money. Agree? So as a result of that, you find that time value will be minimized when an option is deep in or out of the money. Okay? It has to do with the possibility of your call becoming in the money. So to recap, what affects time value? Everything is on this slide. What affects time value? What time? For certain, right? What else? What else affects time value? What's that? Okay, good. What else? Underlying. No, not underlying. Because when we look at time, okay, when we look at any of the factors that affect the value of an option, we are holding all the rest constant. Okay? So when we look at time, we consider all other factors constant. So of course time is one factor. What else affects? The moneyness of an option, right? The proximity between the strike price and the underlying price, okay? Which is the last 2 points here, or the last 2 points here, okay? How close an option is to the money, okay? That's your moneyness. So if you answer a question like this and talk about just time and not moneyness, then you get half the marks, okay? So time value decays closer to expiration, which is why you find that as an option gets closer to expiration, time value decreases. Okay, because there's less and less chance of an option becoming in the money. So what I have here is a graph that depicts the value of an option. Now you notice that this is a curvature and not a straight line. That's because of the time value. Okay, now time value doesn't behave in a linear fashion. It decays, but it doesn't decay in a linear fashion. Okay? So as time gets closer to expiration, you find that it collapses into the intrinsic value. All right? So if you look at this table here, a call option is worth less when expiration is closer. In other words, the longer time you have before the option expires, the greater is the value of the call. If we have the same strike price, one expires in June, one expires in October. Now you can find, whether you look at bid or ask, you can find that the value of a call is greater for a longer dated option than a shorter dated option. So what is time value here? Strike price $16, $15.74 stock price. Suppose this is a call. How much is time value? Let's just look at 47. Okay? How much is time value? $0.21. A call. What do you think, sir? What is time value? Option value equals to intrinsic plus time value, right? So option value is 47 cents. How much is intrinsic value? This is a call. Is this in or out of the money? Out of the money, so 0, right? So time value is 47. Very good. If this were a put, how much is time value? It's a put in or out of the money? In the money. So how much is time value? 47 minus 26, right? Okay? So next we look at the effect of exercise price. So now we have two calls differing by only the strike price, X1 and X2. So which one is greater? The one with a higher strike or the one with a lower strike? Lower strike, right? Why is it higher value? Because then you get to buy the stock at a lower price, right? Okay, so a call with a lower strike would always be priced higher than a call with a higher strike. What about the put? What do you think? Would a higher strike cost more or would a lower strike cost more? Higher, right? Okay. By how much? Well, by the difference between the strike price. So what we're saying is that the difference between the strike price is always greater than the difference between the option price. So we can prove that as well. So when you have two strike prices, you have three possibilities. Okay? So S can be less than both strike prices, can be in the middle, or it can be greater than both strike prices. So you long a call at a lower strike and you short a call at a higher strike. So is this capital outflow or capital inflow? When you buy a call at a lower strike and you sell a call at a higher strike, do you end up paying money or you receive money? Receive. But we just said that a lower strike call is going to cost more than a higher strike call, right? In the preceding slide, right? A lower strike call is worth more than a higher strike call. Okay? So do you end up paying money or receive money? If you buy a lower strike call at a higher price and you sell a higher strike call at a lower price, do you end up receiving money or paying out money? Paying out money, right? Now, if both calls are out of the money, you get 0. If call 1 is in the money, it's positive, and call 2 is negative. When both calls are in the money, this is ST minus X1, this is ST minus X2. Always remember this negative sign when you short an option. Okay? So what do you get here? X2 minus X1, right? So invest in the difference of the strike price. You get the strike price, the difference regardless. Okay? So which portfolio is greater? B is greater than A, right? Okay. Now, if this were not true, is there still an arbitrage opportunity? What do you think? Okay, we're saying that a lower strike call must be worth more than a higher strike call. Okay? So if this is not true, is there an arbitrage opportunity? Suppose now, instead of 72 and 47, so you see a lower strike call is worth more than a higher strike call. Okay? Now suppose this is not true, and you flip the 47 and 72 cents over, such that a lower strike call costs less than a higher strike call. Is there an arbitrage opportunity? Yes. What can you do? You buy the lower strike call, or do you sell the lower strike call? Buy the lower strike call, and what do you do with the higher strike call? You short. So do you receive money in the process, or do you pay money? Now it's flip over, right? 47 in top. You receive money, right? So you start off receiving money, and what happens after that? So you long one call, so you can exercise at 15.50, right? You short one call, you will get exercise at $16, right? After you exercise your call. You follow? So which one is going to be profitable first? 15.50 or 16? 15.50, right? So you started off buying the lower strike call, selling the higher strike call, receive the difference in premium because we flip it over. And when your call, the call that you long becomes in the money, you are profitable again. And the 16 call is not profitable yet. When the 16 call becomes profitable, you may have to deliver the stock, right? Because it can be exercised on you, you short the call. However, you are already 50 cents ahead with your 15.50 call. Does everyone follow? Yes or no? Okay, so you have, how much was that? You pay 47 cents, you receive 72 cents, right? So you get a positive, agree? From the premium. Yeah? So when this call at 15.50, let's say stock price is 16, okay? So now you have 50 cents profit. Now, it's still zero, right? So this is stock price, this is strike price. So you long this one, right? You short this one. Does everyone follow? So when you long the lower strike, you are profitable when it's $16. You short the 16 one, you still have no obligation when it's $16, right? So you already made a profit here. Now let's say it goes up to $17. So how much do you make here? You make $1.50, you lost 50 cents here. Right? Yes or no? Yes or no? Do you follow? Can you follow?
What did you get to 78? Sorry.
The preceding slide. If you look at the preceding slide, I'm saying that a call at 15.50 must be worth more than a call at $16. Okay? And it shows at 72 cents and 47 cents. Now I'm saying that if this were not true, you flip it over such that the call at 15.50 costs you 47 cents and $16 costs you 72 cents, then there is an arbitrage opportunity because you can buy the lower strike call and sell the higher strike call and earn the difference in premium. At the same time, when both calls become in the money, because you long the lower strike, you are in the money more than the call that you short.
So, is that 72 instead of 78?
Sorry?
That's 72.
Oh, they're right. I wrote 78, is it? Okay, it's 72.
That's 79.
It's 72. Does the rest follow? Yes or no? Are you people at the back good with this? Can you understand or not? Can you understand or not? Okay, I'll write it again. 15, 50, and $16. So it's now 72 and 47 cents, right? So this is the call, this is the strike. Okay? So this is what we're saying. Now I'm saying that if these two flip over, there will be an arbitrage opportunity, right? Because now you're going to buy this call and pay 47 cents, and you're going to sell this call and collect 72 cents. So you make a difference from the premium, right? Now, because you long this call and you short this call, when this call is in the money, this call is not necessarily in the money, right? So you're profitable first. Now, when this call becomes in the money, such that you have the obligation to deliver, this call is even deeper in the money, right? Because there's a difference of 50 cents, right? So if the price is at $17, then you're going to lose $1 here. Agree? Yes or no? And you're going to make $1.50 here, right? So you're going to profit from both the premium as well as the payoff. Okay? So the benefit from buying a call with a lower exercise price will not be greater than the difference in exercise price. Otherwise, there will be an arbitrage opportunity, as I just showed you. So 78 cents is the fair value taken as the middle ground between the bid and ask price. So next we look at dividend payment. Any question on the preceding example? So I want to make sure you understand, because you can expect to have or to be tested on your ability to identify these price options and to determine whether as a result of that there is an arbitrage opportunity, and if yes, how are you going to capitalize on that? Okay, so I want to make sure that you are able to identify that and you are able to capitalize on that. Is there any clarification question that you want on the preceding example? Are you good, ma'am? Are you good over there? Yes? If not, don't be shy to shout out. Okay, next we look at dividend payment. Now, when the stock pays a dividend, now in options we're not so much concerned about dividend announcement as about payment. Okay, so a stock will usually announce a dividend to be paid at a certain date. So we're more concerned with when the dividend is going to be paid. Okay. Now, every time a stock pays a dividend, you need to adjust the stock price with the amount of the dividend. The reason for that is because when a stock pays a dividend, the stock price tends to drop. Okay? After paying a dividend, the stock price tends to drop. So if a stock if a stock pays a dividend of, let's say, $1 tomorrow, after tomorrow you find that the stock price is likely to drop by at least $1. Okay? So to account for that is very simple. All you have to do is you adjust the amount of the value, the amount of the dividend against the stock. Okay. Now, what is more important is the implication. Okay, the implication of a dividend payment, because it will help you to decide whether or not you want to exercise a call or put early, and also whether or not there is a value in your ability to exercise early. So last week I asked a question, is American calls worth more than European calls? I think the answer for most people is yes, right? Simply because you can exercise early. So today we'll look at a situation where it is not necessarily true. Okay, just because you can exercise early doesn't mean that there is value in that ability to exercise early. So are American calls worth more than European calls? Well, yes, only if the stock pays a large dividend. Okay? So why is an American call worth more than a European call when the stock pays a dividend? So here's the logic. When a stock pays a dividend, the stock price goes down, right? So at this point in time, this is the stock price. After it pays the dividend, the stock price goes down. Now at this point in time, your call may be in the money, right? Right? But at this point in time, your call could be out of the money, okay? Because S has decreased in value. Yeah? So as a result of that, if you are holding an American call here, it is more valuable than a European call, right? Because you can exercise while you are in the money, right? If you're holding a European call, you can't exercise, right? You can only watch the option becoming out of the money. Okay? So therefore we say that you will never exercise an American call early if the stock does not pay a sufficiently large dividend. Okay? Why is that so? Because if you were to exercise a call or a put, for that matter, now when you exercise a call, what do you get? Intrinsic value, right? Because there's no more time value. You exercise it, you don't have the option anymore, right? Now, if you were to sell it back to the market, like what the lady suggested, what do you get? Intrinsic value plus time value, right? Agree? Because the price traded in the market is intrinsic value plus time value, right? So if you sell it back to the market, you get both intrinsic and time value, whereas if you exercise it now, you only get intrinsic value. Okay, so you will never exercise an American call early unless it pays a large dividend, because when it pays a large dividend, you could suddenly become out of the money. Otherwise, you don't want to exercise because you want to still have the time value. And time value is mostly positive. Okay? Now, can someone think of yet another reason why you won't want to exercise a call early? Because I've given you one reason, right? Because you have time value, right? So you don't want to exercise it. What is another reason that you can think of?
You need the money recently.
You need the money recently. So if you need the money recently, do you want to exercise or not? You don't want to exercise. Right. So you don't have money to pay the strike price, so you don't want to exercise. Now, even if you have the money to exercise, would you want to exercise? Okay, I'll help you out. So you have the money to exercise now, but in not exercising, suppose it doesn't pay a dividend, right? So the risk of it dropping or the risk of you becoming out of money is less, right? So suppose you have the money, would you still want to exercise? The first point you look at is that you don't want to because of the time value, right? What is another reason? You have the money to exercise, but you don't want to. You don't want to is correct, but what is the reason for that? Okay, if you don't exercise, if you exercise, you pay out the strike price, right? So you have to give up your money. If you don't exercise, what happens to this money? Hold it back. Under the bill. Hold it back. The bank, very good. And what happens to that money? It earns you interest, right? So therefore we say call save you money. Okay, by not exercising the call, you can put the strike price either in the bank or in some other investment to earn you a return. Right? When you pay out the strike price, you lose that return, right? So that's another reason for not exercising a call early. On top of that, you find that with a call, the payoff is S minus X, right? How far can S go?
Infinity.
Don't know, right? You don't know, right? So potentially you can be very deep in the money, right? Okay. Now, what's the worst situation? If the stock price drops to 0, right? If it drops to 0, what happens? Nothing happens, right? You only have the right, not the obligation. You just walk away. Now, that's not the same with a put, okay? So we'll look at that later. So calls save you money. Okay, I've just explained this. So intuitively, you also know that the higher the interest rate, the greater is the value of the call. Agree? You can reason that out, right? Because you know that your strike price is earning you, at the very least, a risk-free rate of return, right? So as interest rate goes up, the value of your call must go up as well, right? So if you think in terms of this, then when you look at put, you can switch over quite easily, okay? So stock volatility, the higher the volatility, the higher the value of a call. Who disagree with this? So suppose I have something here. So this is a chart that depicts your instrument, whatever it is. So if this is a stock, do you want this kind of volatility? It still goes up, so if you buy a stock, you still make money, right? Right? But do you want a volatility like this? Why not? Okay, let's make it more interesting. Okay. Would you want a volatility like this if you are invested in a stock? It still goes up, you still make a profit. You don't want, right? Because on days like this, you might not be able to sleep, right? Okay? If you need your money here, you'll be in trouble, okay? However, if this were an option, do you want something like this? Yes or no? Why?
Always exercise this at a certain price, and so that element eliminates the downside risk.
Well, the downside risk is not eliminated as you mentioned, but the downside risk is 0 because you have the right, not the obligation from a buyer's perspective, right? However, volatility like this is good because if this were your strike price, okay, now you may be out of money here, but you could be in the money here, right? Now, if the chart moves like this, then this is probably good for you if you're holding the stock because it still go up, but it's not good for you if you're holding an option because there's less chance of an out of the money option becoming in the money, right? Okay, so when you trade options, you want a lot of volatility. Okay, and you will learn later on that you actually don't even need to look at the price of an option when you trade. You only need to look at the volatility. Okay, so as volatility increases, the value of your option increases as well because maximum loss on a call is always 0. You only have the right? You just walk away. Maximum loss on a stock is of course the stock. Okay. You want to take a short break or you want to go on? I'm happy either way. You need a break? Okay, tell your friends, those who are not here, tell them about the app so that they can. Okay, with puts, you'll find that there are a number of variables in puts which affect puts in the same manner as they affect calls. Okay? So where they affect both options in in the same manner, I won't go into explain too much. If you have understood that for a call, you should be able to apply that to a put. Okay? I'll explain those variables for which they affect a put differently from a call. Okay? So, but I have included all the slides on the put for you as well, so that it makes it easy for you to revise. So what's the minimum value of a put? Now the main difference you need to be conscious of is that with a call, the payoff is S minus X, right? Now in the case of a put, the payoff, you flip it over, right, is X minus S. So be conscious of that when you look at the variables as they affect an option, and that way you'll be able to figure things out. So what is the minimum value of a put? We say that it's 0. And again, when does that happen? When is a put? Again, we're talking about a buyer, okay? The long. When is a put 0? How come that one is not? Has it always been like that? Okay, when is the put equals to 0? When it's in or out of the money? Out of the money, right? Why is it 0? Not negative. Again, with your rights, right? And not an obligation. So for the same reason, inequality sign, present value. Okay? So how does this look like? This is a long put. So if the stock price is less than X, you are profitable, right? This is 0. So if a short put, where is the line going to go? This way? This way, this way. Where's the line going to go? Somebody draw it for me. Which way? Mirror image, right? So it's going to be this way, right? If you short a put, and the put is in the money, when S is less than X, you have an obligation. Okay? So if you short a put, is your payoff going to be positive or negative? Negative. Positive or negative? Negative. Sure? Will it ever be positive? Okay, very good. Looks like you got a pretty good grasp of it. Okay, this is the same payoff table that we use to prove that for a call. We can use the same for a put. Does everyone understand how a payoff table works? Okay, you simply create two portfolios to prove what you want. So again, you short a put. Okay, so always remember the minus sign or you get it all wrong. Okay. So here I have a June put contract, 1574, time to expiration. What is the intrinsic value? Is the put in or out of the money? So things like this, you must be very fast already. In or out of the money? In the money, okay. So is there time value here? So look at these two, American and European. What is the difference? What is the difference? Which is worth more, American or European? American or European? It's on the slide. European is worth more than American. It's on the slide. Just read out from the slide. American, right? So what I want to point out to you is that in the case of a call, an American and a European call would normally be about the same. Okay, American can be slightly more than European, but it tends to be quite close together. Now, in the case of a put, American puts tend to be greater value than European put. And as we move along, you find out why. Yeah, so I will save that question for a little bit longer. So what is time value here? So this is a put and it's in the money because X minus S is positive, right? So intrinsic value is how much? 26 cents, right? Yeah? However, it's trading at 60 cents. So what is time value? 60 cents minus 26 cents. Okay? Okay, very good. So what is it at expiration? Again, at expiration, regardless of a call or put, is always either in or out of the money. If it's out of the money, it's zero. If it's in the money, it's a positive value. Okay? So effect of time to expiration. So again, just like calls, now you have two puts. The first put is at a shorter time to expiration, longer put 2 is longer time to expiration. Which put is going to be worth more? The one with a longer time to expiration or shorter time to expiration? Longer time to expiration. In the case of a call? Longer, right? So time value or time to expiration is good for both, right? Okay, because as we explained in call, it gives you more chance when out of the money call to be in the money, and for the same reason, it is maximized at the money and minimized deep in or out of the money. As we explained, for call, it applies to put as well because any small fluctuation is going to throw your put out of money as well when it's at the money, right? Or near the money. Okay, so recognize the difference between a call and put, and also the similarities. Okay. So again, because of time value, it is not a straight line but a curvature, and at expiration it always collapses back to your intrinsic value because time value becomes zero. So again, from here you can see a put with the same strike, different expiration. You can find that a longer dated put is worth more than a shorter dated put. What is the difference here? 11 cents, right? So if this is a call, is this in or out of the money? In the money. If this is a put, you sure you get it correct or you get it the other way around? If this is, okay, if this is a call, is this in or out of the money? Out of the money. If this is a put, it's in the money. So if this is a put, how much is time value? Can you tell? Let's look at the first one. So this put is in the money, right? 16 minus 1574. So 26 cents intrinsic value. Time value is equals to? Okay. So now again we compare strike price. Which one would be greater? A lower strike put or a higher strike put? Which is more valuable? Sure. Who thinks lower? No one. Very good. So a higher strike put is worth more than a lower strike put, right? Why is that so? You sell at a higher price, right? So that's opposite from a call, right? A lower strike call is more valuable than a higher strike call. Looks like you're getting a hang of it. So again, with calls, the difference in the strike price will be greater than the difference in the option price. Okay, And if that were not the case, you would again have an arbitrage opportunity as what we saw in a call. So you find here, same expiration date, different strike. A higher strike is worth more than a lower strike. What is the difference between the strike price? 50 cents. Difference between the option price? Less than 50 cents. Okay? So the cost from buying a put with a higher strike price will not be greater than the difference in exercise because of no arbitrage, as we saw in the example for call. Is put more difficult? Do you find put more difficult than call? Or is it still easy to flip around? What do you find it? Because a lot of people, when they first learn option, they find that call is easy to understand. Put is so hard to understand. Okay? And they find that buying an option is so easy to understand, selling an option is so hard to understand. Okay? But that's not necessarily the case, right? Which is why I want to encourage you to think, as I explained, so that you can see the difference, you can easily flip over. Okay? Okay, dividend payment. Now, how does dividend payment affect a put? Again, with dividend payment, what you want to be able to do is, again, adjust the value of the stock or the price of the stock with the dividend payment. Okay, for the same reason, you're interested in payment, not only on the announcement. And whenever a stock pays a dividend, you always adjust the stock price with the amount of the dividend before you evaluate your payoff. Okay? So in the case of a put, is dividend payment good or bad? Good. Call? No, bad. Can you? Depending, actually it all depends on the size of the dividend, right? If it's large enough, then it has an effect. If it's not large enough, then it's not. In subsequent chapters, we'll evaluate that. So how does a dividend payment affect a put then? So in the same way, if a stock pays a dividend today, the stock price goes down, right? Yeah? So is your put going to be in the money or out of the money? In the money, right? So again, look at two scenarios. This is before dividend payment. This is after dividend payment. Okay? The next day. Now, before dividend payment, your put is, let's say, in the money, right? After dividend payment, so okay, this is the stock price. Before dividend payment, after dividend payment. So before dividend payment, let's say your put is in the money. After dividend payment, is your put going to be in or out of the money? Deeper in the money, right? So when would you want to exercise your put? Here or here? Here, right? After dividend payment. Now, if this were a call, and your call is in the money here, is your call going to be in the money here, after dividend payment? May not, right? Well, likely not. Let's say it won't be, right? If it's a large dividend payment. So then your call is in the money here, it's out of the money here. When do you want to exercise your call? Here, right? So there's a difference, okay? You want to exercise before dividend payment. In the case of a call, you want to exercise after dividend payment, and ancillary to that also is that dividend payment is good for a put, but not as good for a call. Okay? So Americans puts worth more than European puts. Now earlier on we said that an American call is not necessarily more valuable than a European call, right? Remember? Can someone remind me why that is the case? Why is an American call not necessarily more valuable than a European call?
to be in the money. If the dividend amount is not negative, it would be not. It may be.
Okay, think in terms of being in the money or out of the money. Okay, or deep in the money or deep out of the money. Now, in the case of a call, how deep can you be in the money? How deep can you be? So you're in the money in the case of a call when S is greater than X, right?
Yeah.
So how deep in the money can you be? There's no limit, right? Because there's no ceiling to a stock price, right? You can go to whatever. Now, in the case of a put, when are you in the money? When X is greater than S, right? And when are you deep in the money? What is the maximum? S equals to 0, right? So there is a floor, right? You cannot go beyond 0, right? So as a result of that, you find that in the case of a put, there is always a situation where you want to exercise early, right? Because if S is close to 0, you can only go back up, right? So if you don't exercise your put now, you might lose the chance, right? Now with a call, the stock price has no ceiling, right? So you're not under as much pressure to exercise the call as a put. Does everyone follow? Yeah? So as a result of that, you find that an American put tends to be of greater value than an European put. Okay? So in other words, the ability to exercise early in the case of American options is more valuable for a put than a call. Okay? Now, as a result of that, can time value, now we all said that time value is mostly positive, right? Now I want you to think about this. When can time value be negative? For calls or for puts? Call? Time value negative for call? For call or put? For put. Right? Why?
When the share price is very low, you want to exercise now.
Because you have a floor, right? But you don't have a ceiling, right? So time value can be negative in the case of a put, right? Now, would it be an American put or European put? European, right? It makes sense because American you can exercise and therefore capitalize on the opportunity. With a European put, you cannot exercise. So if you can only exercise on Friday and today the stock price is close to 0, then you'll be quite frustrated, right? Because the price is going to go back up and you will lose your opportunity to exercise the put. So with an European put, time value can be negative. Okay? Is it easy to reason out that way? Yes? Does it help you to think through the process? Okay. So next we look at interest rates. So we said earlier on that calls save you interest, right? So it saves you. Calls save you money because you don't have to pay out the strike price. So with put, does it save you or cost you money? It costs you money, right? Because by deferring to exercise your put, you're deferring the collection of the strike price. Yes? Yes. Okay, good. So with that in mind, would you ever exercise an American put early? What did we say about call? Would we ever exercise an American call early? If it does not pay a dividend? Would we exercise an American call early if it doesn't pay a dividend? What do you think, sir? We just looked at that half an hour ago. Would we ever exercise an American call early if the stock does not pay a dividend? Yes or no? Forgot already. You won't, right? For a number of reasons that we mentioned, right? Okay? amongst other things, call save you money, there's no ceiling to the underlying, and so on and so forth. Now, in the case of a put, would you ever exercise an American put early? You would, right? And even if it pays a dividend, then you would even want to exercise, right? Now, even if it doesn't pay a dividend, you would still want to exercise an American put early. For what reason? So that's how you think. If you have understood call, this is the opposite, right? So for what reason? Why do we want to exercise an American put early? What do you think, sir? You. Yeah. Do you agree that you want to exercise an American put early? Okay, why? Doesn't matter if you get it wrong. Okay, it starts the process of thinking. Why? You want to help him?
Exercise.
Yeah. Would you want to exercise a put early?
Yes.
Why?
If it's already taking the money,
Yeah.
you should achieve a profit first. Because otherwise, there's always a chance that stock price will go up.
And that likelihood is even greater in the case of a put than a call because of the floor and ceiling thing, right? Okay. What else?
We can exercise and get the cash every.
Very good, because when you exercise a put, you receive the strike price, right? So when you have the strike price in hand, you can earn you a return. Now, in the case of a call, when you exercise, you have to pay out the strike price, right? So you lose that return, okay? Is that easy to follow? All good? Some of you seem to grasp it very quickly. So some of you, I'm not sure because you're very quiet. So maybe you want to speak up a little bit more so that I know. Now, if you don't understand, please shout, okay, so I can, because I want to make sure that you understand this is a very important fundamentals for you when you move forward. Now, volatility. Is there any downside risk? Is volatility good or bad for put? For the same reason, right? As a call. Okay, let's do a recap before we move on. Stock price increase or underlying price increase, is this good or bad for your call? Okay, this time shout louder, okay, so that it means more people have the same view. Okay, stock price increase, call price good or bad, positive or negative? Still very soft. Come on, more people. Put negative, okay, better. Strike price goes up, good or bad for call? Bad. Good or bad for put? Good. Interest rate goes up, good or bad for call? Good for call? Good or bad for put? Bad for put. So what does that mean? So when the interest rate goes up, would you expect the value of the put to go up or down? Huh? Huh? You just say it's bad. You just say it's bad, right? So I hope you understand this. Okay, so when you answer something like this, it tells you that you're still not certain. Okay? So it's important to know that, because then you know that this is one area you want to reach out a little bit more or come to the consultation and clarify. Okay? If otherwise you might think that you know, but in actual fact you still don't know. Okay? So take this with right attitude. Okay, so with what else are we missing out? Time, right? So with time, time to maturity increases. Is this good or bad for call and put? Good? Is both good? What are we missing out? Dividend. Dividend increases, so pays a large dividend. Is that good or bad? Good for call, bad for put? Bad for call, good for put. Bad for call, good for. Okay, are we missing out anything? Volatility, good or bad? Both good. Okay, very good. Early exercise. Still remember the things you need to consider for call and put, the difference between when you decide whether to exercise early a call and put, how the same factors affect differently your decision. Okay, good. So put call parity. Okay, describes the relation between a put, a call, a stock, and a bond such that no arbitrage occurs. Okay, now when you use put call parity, it is important that you be mindful that your call and put is in respect of the same underlying. Okay, interest rate is the same, and time to expiration is the same. Okay, now it is a relative pricing model, so not as accurate, but it is good enough if you get it within the bid-ask spread. So what is put call parity? Well, if you go long, is this long or short? Take a put. Long or short when you take a put? Okay. Long, very good. So you take a put, okay, and you long a share. Put is in or out of the money? Here? Okay, you must be very fast now. Okay, in, out, money, long, short, you must be very fast now. Okay, so this in the money, out of money, therefore is 0. Longer call, invest in the present value of X, gives you X. Which portfolio is of greater value? B is greater value? Which one is greater value? Same, right? Put call parity. Come on. It has to be the same, right? ST goes out left X. This is also only X, right? X plus 0. ST, X cancels X, so it's only ST. So both portfolios are equal. So therefore we can say that a put plus a stock is equal to a call plus a bond. So that's your put call parity. So you can rearrange this formula in any manner you want. So for example, if you want to determine the value of a put, you simply bring your stock over here. So a put is equal to a call plus a bond minus a stock. Okay? So you just rearrange it to suit your needs. Now, in the case of an American option, it won't work as well. Okay? Now, the inequality sign there is a result of the potential early exercise that American option gives you. Okay, so for put call parity to work perfectly for American options, you would have to hold that to expiration, because when you hold to expiration, early exercise is out of the equation, right? So here I have a put and a call, 60 cents, 52 cents. So why is put greater than call? Quickly, why is a put worth more than a call? Which one is in the money? Put is in the money, right? Okay? So therefore, it has to be worth more than a call. Okay? Remember, it's always intrinsic value plus time value. So if it's in the money, you have both. If it's out of the money, all you have is time value, right? Okay, so therefore put value is greater than call. Now if you stick in the numbers to show that put call parity holds, okay, a call is 52 cents, bond is $16, which is your strike price, 60 cents for put, 15.74 for your stock price, you find that put call parity holds, okay? Now you can try that out in any real prices you look at. You find that put call parity would normally hold. Now sometimes it doesn't hold for a variety of reasons. Okay, it could be because the interest rate was wrong, or liquidity or transaction costs and so on and so forth. Okay, but so long as you get it, if you are trading, so long as you get it within the bid-ask spread, you are more or less correct. Now, an at-the-money call option must be worth more than at-the-money put option on the same stock. Why is that so? Now, without looking at this slide, how many of you would have figured this out? An at-the-money call, okay, let me ask you this question differently. Would you expect an at-the-money call to be worth more or less than at-the-money put? Intuitively, just think about it. This will help you in your exam because you can figure out call. Why do you think at-the-money? Now, at-the-money means S is about the same as X, right? Or the same as X. So why do you think at-the-money call is going to be worth more than at-the-money put? Very good, because call saves you money, right? So call saves you money, it means that you're earning a return from your X. But put costs you money, and so therefore you're losing the return from the X, right? So intuitively, you know that at-the-money call must be worth more than at-the-money put, and by how much? Again, if your answer, as the gentleman did, is because of the call save you money or puts cost you money, then the difference has to be due to something related to money, right? And therefore, it is the interest rates, right? Because in one case, you are earning the return. In the other case, you are losing the return. So therefore, the difference has to be the return. In this case, is the risk-free rate, okay? Any questions so far? So if you substitute S with X, it's the interest rate, right? Difference between present value of X and X, or present value of S and S is the interest rate. Okay, let's conclude with and pricing of a call. Okay, any question so far? Does anybody want to clarify anything? Ask any question? Is it easy to follow? You need to follow? Okay, so a share is priced at $10. It can go up to 11 or 13. Risk-free rate is at 12%. Strike price is at $12. So how do you price a call? Well, first you buy a risk-free asset. So you know that stock price can be 11 or 13, right? And in order to get 11 at a future point in time, given the prevailing interest rate, you stick the present value of 11 into the bank, you will get $11 in a future point in time. Okay? So everyone follow? Now your payoff is therefore 11 in this case, right, from the bond. Now, because strike price is $12, stock price at $13, well, if stock price is at $11, strike price $12, you're out of the money, right? So all you're earning is from your bond, right, the first part. Now, if stock price is $13 and strike price is $12, your call is in the money, you earn $1, right? Now, you know from 13 to 11 is $2, right? So you need 2 calls, okay, because you need to earn $2, okay? So in summary, this is what happens. So when the stock price is $11, your bond gives you $11. Your call is out of the money because the strike price is 12. Does everyone follow so far? So your total is 11, okay? Now if the share price is $13, your bond still earns you 11. However, you have 2 calls, right? Each earning you $1. So in total, you still earn $13, regardless, okay? So therefore, what is the value of your call? This is just simple algebra, right? Okay?
Is that assuming the
So 12 is the interest rate, yeah?
Is that assuming the outcome of 11 and 13 are equal chance?
Yeah. At this stage, you can assume that. But once we go into binomial next week, then we will look at the probability and so on and so forth.
And I will change the price.
Yeah. And when we look at binomial, also we will also look at how to calculate the value so as to determine whether or not there is a value in your early exercise. So if not, then you use certain value. If yes, then you use the higher value to value your call. Okay? So that's all I have for today. I hope you find it easy and interesting. So share with your friends the app, okay? And we'll talk about that in greater detail. Before you go, maybe we have a bit of time, right? I'll just show you in the real world, okay? So this is what we have. I pick up on BHP. Now, think about what we just learned in today's topic. Okay, what can you see here? Now we said that in the case of a call, a strike price increases. Does the value of a call increase or decrease? A strike price increases for a call, the value goes down, right? That's what we learned. Now in the case of a put, again, a strike price increases, the put value goes up. You can see here, right? So this is extracted from ASX. Okay, so every day you can look at prices. If you're interested, you see all these theories playing out in front of you. What else did we talk about? We talked about time to expiration, right? The longer dated option is worth more than a shorter dated option. So this expires in March, this expires in April, and this expires in June. So let's look at something of the same strike price. 16.50. Okay, strike 16.50 expiring in April is $1.47. 16.50 expiring in May is $1.73. Right? So it's greater. 17 is $1.20. 17 is $1.45. If you look at a put, 16.50 is 67 cents. 16.50 is 89 cents. 17.50 is $1.09, 17.50 is $1.32. Just like what we learned earlier on, the more time to expiration, the higher is the value of your option. What else did we talk about? Volatility is, can't show you here, interest rate, not here. Strike prices. Okay, difference in strike price. We say that the difference in strike price must be greater than the difference in option price, right? So let's see. 16.50 and $17. So 50 cents difference. What is the difference between the option price? Less than 50 cents, right? Let's see if it's true for a put. So, okay, this one is not traded, so we can't look at this. 17.50 and $18. So again, 50 cents difference. This is also less than 50 cents difference. Okay, so many of the concepts you just learned in this lecture, if you are interested, you go and look at the prices in the market. You will find that they actually play out. And
the advantage of that is that I think it will help you to consolidate the understanding when you see it happening in the real world.
Okay, so that's all I have for today.